Some guidance for it. I thought this was interesting. If you look at the left side, this is part of that recommendation from Schneider as to what you're supposed to do for this or in general any other ICS specific attack. They mentioned device protection and hardening, workstation hardening, network hardening, perimeter hardening. And I looked at it and I thought, huh, even if there was no in controller, even if you go back 10 years ago, back to Stuxnet, what would be different in our recommendations? Nothing. That's what prompted me to talk about this, right? We focus so much on 0 days, we focus so much on nation states attacking each other, but all said and done, the recommendations are no different from yesterday. It doesn't matter what the attack is tomorrow or the day after. What we recommend doing is exactly the same. But you can take the OPC UA recommendations, right? So the toolkit that we talked about that has both the generic PLC attack vector as well as the OPC UA, same thing. Look at the recommendations. First up, proper segmentation of IT and OT. Well, this is what any OT practitioner would recommend on day one, proper segmentation. Allow listing. This is fairly common in ICS networks, a lot easier compared to IT to do allow listing. And you go down the list, industrial firewalls, monitoring and blocking of traffic, enabling and aggregating audit logs. If you go down the list, every single one of them is a recommendation that OT practitioners have been issuing or talking about for a long time. So nothing that InController provides or any other attack, any other toolkit is going to change these recommendations. Right? Let's put all these in perspective. Project Basecamp. How many of you have heard of this one back in 2012? So one, two. I strongly recommend you watch the video from Ray Whitman and Dale Peterson on the S4 channel. I put 2 links here. I'll share this with whoever wants. But it's amazing that back in 2012, they looked at a few controllers and said, let's do an evaluation, let's do an investigation of security of these controllers. They found, in fact, they had to stop in a couple hours because it was so bad. This is 2012. And they said, it's not really worth it because proper credentials, hard-coded credentials, reused credentials, all basic stuff, right? Authentication, access control. It was pretty bad in their list of things. So they had red check marks against every controller. It was so bad that they stopped and let all those OEMs of the controllers know. They said, hey, your systems are so bad, go fix it. And 10 years later, they actually did another video recently. It's not on YouTube yet, but it'll show up soon enough. Nothing much changed, folks. The older control systems, nothing much has evolved. The more modern control systems, you can go to the same vendors, GE, Siemens, Honeywell. If you buy a modern control system today, they're much better. They have a lot more security features built in. So they're capable now of incorporating a lot of security into the infrastructure, into the project, right? But the older systems still remain in play. None of these systems are replaced overnight. So unlike in IT, right, the traditional OT systems are not replaced every 3 to 5 years. They're replaced every 15 to 20 years. So something that was bought for and paid off in 2000 is still up and running, and it's still insecure by design because it doesn't have access controls. It doesn't have authentication. It doesn't have any security features, no encryption, for example. There's a list from Temple University. They publish this. You have to sign up with your email, and they'll make sure that you're not a malicious attacker, right, to be able to give you this list. But this list has more than 1,200 records of all known or disclosed incidents, right? Most of them are ransomware, but they have a whole slew of items, and they map everything to the MITRE ATT&CK framework. And almost every one of you have heard of the MITRE ATT&CK framework. There is a section for ICS as well, so that's something you might not have looked into, but there is a specific section which includes some unique things for ICS, right? Like loss of use, loss of safety, loss of production. That's not directly related to IT, so they have a specific section for it. So I recommend you take a look at MITRE ATT&CK for ICS. But the key is, if you look at the overall picture, Again, it goes back to my list where targeted nation-state attacks on industrial control systems do exist, but they're not the vast majority of the attacks. Of those 1,263, if you remove these 6 or 7, the rest of them are not ICS-specific attacks, right? They were from IT, they were from insecure remote access, they were from some kind of collateral damage, not necessarily targeted at ICS. So the extended landscape, why is it an issue in OT, right? So most of OT control systems are proprietary hardware with unique protocols because these were developed when there was no equivalent IT protocol or IT hardware to just leverage for OT purposes. So back in the day, control systems were hydraulic, pneumatic, previous to digital, right? So control systems existed before there was anything electronic or digital. So when they were adapting control systems with digital, they had to come up with their own. So the GEs and Siemens and Honeywells of the world designed their own control systems. And at the time, safety and reliability were the requirements, not necessarily security, right? So the protocols were developed with no security in mind. So safety and reliability, yes. Security, no. So it's also called insecure by design. Some people hate this because, well, it was never requested of the engineers to incorporate security. So how could you call it insecure by design? Because you never asked those engineers to develop something with security in mind. And then flat networks. This is a pretty big issue. Pretty much every industrial site you go to has a pretty flat network. More common in some applications like manufacturing, where you walk on the factory floor, touch a device, you can log into any other device across the network, across the floor, across the company, across the WAN, across the whole company in the OT world because it's one network, right? Because usually it's like 1 or 2 guys that manage it and maintain it. A lot easier for them if it's all on the same network, right? Copying files, transferring content, connecting to billing systems, for example, connecting to the SAP world, connecting to the tool shop, inventory system, whatever they might be. A lot easier for them if it's a flat network, so it's fairly common. So that's why the collateral damage, right? If you affect one system, you have access to the whole network. Patching is not always possible. This is, again, a big problem compared to IT. In IT, what do? Right? As soon as there is a known vulnerability, an exploit or whatnot, you're like, what's the patch? The first thing you do is go find out from the vendor, from Microsoft, whatever the case may be, find the patch, apply it, so you're good, right? That's your mitigation. In the OT world, that's not practical at all. Number one, patch might not be available because, yeah, 20 years ago, this system has been obsolete for 15 years. So there's no way a vendor patch is available. Or the vendor himself or herself is out of business, right? Because that's a vendor that you bought from 20 years ago, 30 years ago. They don't exist anymore. Testing and validation. There's no lab, there is no demo, there is no place to test and validate. You have to test in a representative environment, and you just can't do it. The only time you can test or validate is during an outage or a shutdown. That only happens every year, every 3 years, every 5 years, every 10 years. So you might not be able to validate. There is no redundancy, so that system is down. You're validating, you're testing, your production is impacted. No outage window available. The vulnerability is not disclosed or unclear if exploitable. That's the other thing, right? So yeah, just because you have a vulnerability in the IT world, because everything is connected to the internet, by default, we assume that it's exploitable. If one exploit exists out there, it's exploitable everywhere, right? In this world, if you properly segment and isolate, it might not be exploitable. Maybe it needs admin credentials. Maybe it needs certain access that that particular HMI or workstation doesn't have. So there are many other things that make the exploit maybe not relevant to your environment, right? That needs to be validated. The last one, not always relevant to risk reduction. This is something very difficult for a traditional IT person to understand. Going back to insecure by design, taking Modbus, protocol and industrial control systems. It's hardly ever used for control these days, but at least you've heard of it, right? OPC UA, we talked about OPC before. There is an insecure version. There is a secure pathway to implement it. There is an insecure way to implement it as well. So those protocols, especially if you have no authentication, no encryption, they will just follow your command. So if you have access to a fully patched workstation, the workstation itself is patched, but the protocol talking to the control system is not encrypted. So you can command it to do something, just like in the Florida Oldsmar case where that HMI or workstation could have been 100% patched. The controller that it's talking to could also be 100% patched. But if you were able to log into the HMI and just add the content of live, change the set point from 10 to 50, it'll execute. So how is patching relevant in this case? It's not patching. There are other systemic issues in this world, right? Awareness. This is increasing, but we still have people that say we're not a target. Well, yes, you're not a deliberate target, but you're part of the ecosystem, right? Collateral damage. That's fairly common. The other thing you used to hear more is we're air gapped. This is a very difficult challenge. When the first thing that comes out of someone's mouth is we're air gapped, you know for a fact they're not considering their plant as connected or networked. Air gaps don't exist anymore in OT. They're always connected. Like in the Colonial example, even though you think you're physically disconnected, removed, your networks are separate, the fact is you had connections. You had connections to your internal systems, networked internally to your inventory systems, networked internally to your management interfaces. It's like one engineer. I mean, I'll give you an example. If you look at a refinery might have 100 different PLCs. You'll have a few control systems engineers that are supposed to manage the whole set of PLCs, the DCS, and everything. And for them to go in front of the HMI, which is in the plant, they have to put on their coveralls, put on their boots, hard hat, enter through the safe corridor, and get to the plant. It might take half hour to get to that workstation. However, if they connected it to their computer on their desk, they could still perform their job safely, do config and whatnot, and not have to waste 30 minutes to go to the HMI, right? So more often than not, they have connected it because there are other reasons for them to connect it. Even if that's not established, those connections were not documented and nobody authorized it, they've already done so, right? Compliance, remote vendors, access, right? These things exist. Many remote access opportunities exist, especially if you have a compliance regimen where you have to maintain certain emissions or you have to maintain certain quality of product. You have external connections for sure, because how do you maintain, right? Whether it's connecting to your rate payer, rate basis, or connecting to your emission system, you have external connections that are probably not documented properly. And then backups. I saw a meme earlier today about, we lost our server. Hey, where's the backup on that server? Right? That's fairly common in the OT space, where it's not really thought through, right? Where the backups are going. Have you tested, validated backups? Rarely ever anyone does. Management support, this is hard because for lack of all the stuff, right? For lack of inventory, for lack of visibility, for lack of truly understanding what connections exist, what your inventory is in your OT world, how could you ask management for support? Like, what would you ask? Like, you go in front of management and say, oh, I need to improve my OT security posture. Well, where do you start? Right now, they find it difficult to evaluate the risk. In the IT world, there's a lot more documented process, there's a lot more risk awareness, risk mitigation process where you have a clear-cut case to say, these are my assets, this is the risk, and this is the budget that could resolve a certain amount of risk, right? So you have this conversation frequently in IT, not so much in OT. The resources and funding are a big problem because it's very hard for management to make the decision for lack of visibility. Legislation, non-existent in most cases, and when it exists, like in the power sector, NERC SIP, there is a compliance regimen. It's limited to medium and high critical sites, and it's also very prescriptive. It's not very risk-based, right? As in, what A has to do versus B has to do is exactly the same. It doesn't matter if A is on an island where, if you impact that particular site, the whole island doesn't have power, versus you're here in the middle of, let's say, Calgary, where if one site goes down, hey, nobody cares because there's other power producers on the network, right? They try to manage that risk somewhat. They have slightly different rules, but for the most part, it's very prescriptive. It's not risk-based. That's a problem because, um, again, compliance is not security. But even if you follow the compliance procedures, sometimes it's just wasted dollars, wasted effort because you're not actually fixing the risk, but you're just doing something because you have to follow legislation. In many other cases, other critical infrastructure other than power, except for the most recent oil and gas, and the TSA came out with a certain regulation for TSA pipelines after colonial. The rest of the industries, refineries, petrochemical, there is no legislation. So again, when you go in front of management, ask for funding, you can't really tie it back to I have to do it, right? You can't tell them what the risk is because you have other problems. You can't say I have to do this because of legislation. So you're kind of stuck. You don't know how to make the conversation happen. This is again unique to OT. So long project cycles. Some of these projects take a long time to build. So how many of you have started a project on the IT side and finished it in 6 months? Several, I would think. Other projects might take 2 years, 3 years, whatever, right? But you finished phase one in the first 2 months. You went through multiple phases. You got the whole company covered in maybe a few months or a couple of years. In the OT space, let's take the worst example, nuclear power plant. Well, first of all, you can't even build anymore. These days, you can't get permission to build a nuclear plant. But even if you did, it takes 25, 30 years to get to the finished stage in a nuclear plant. Less so in other industries, right? Petrochemical plants, from the initial design stages all the way to build and production. I commissioned several LNG plants, I commissioned several refineries, several pipeline applications. Pipelines might take anywhere between 2 to 3 years. Some of you have heard of Keystone XL, where it didn't happen for decades, right? Then there are other pipelines that actually got through the permits and approval process and might take 10 years to get there. So long project cycle. So the decisions that you made about security 10 years ago, 15 years ago, are relevant today. And that's a problem because you didn't have any security requirements 15 years ago, right? So when you're building projects, that's one of the problems we have in OT. And then the construction engineering firms that are building this, they're not the ones operating it. That's another problem, right? Where they are forced to think about their current requirements. They're not thinking what could happen 5 years from now, because that's another company altogether that's operating. And then upgrades are CapEx driven. This happens every day. So control systems, like we mentioned, are not replaced for 15, 20 years, and they're typically CapEx, right? So you invested $1 million, $2 million in an upgrade, and your ROI is over 20 years. So you're not doing anything year over year. So no maintenance budget for cybersecurity, because that was never baked in 20 years ago, right? And then public good versus private cost of security. And this, critical infrastructure, whether taking the water treatment plant or in Colonial Pipeline's case, it's a private company, right? They make their own risk-based decisions. So Colonial might be 100% okay with a 1 week downtime for ransomware attacks. But as a country, the US, the Southeast, and some parts of the Northeast, they suffer because gas prices ramped up. People didn't have gas on time. You saw those pictures, those videos of people waiting in line to get gas, right? So that's a public problem. But the cost of security is with a private entity, right? So that's a conflict of interest where critical infrastructure, people depend on it, but the expenditure has to come from a private organization. And then nation states, the whole talk today, I'm trying to tell you that don't focus on nation states, but that one-off chance that nation states do attack a sector or a particular company, that is not a fair game, right? How are you supposed to protect yourself against nation states when your whole OT system was never architected for security? You're now having to deal with nation states. One carrot here in this case is a combination of security, cybersecurity insurance. So in the past, this wasn't a deal, but these days you can't even get insurance without some level of cybersecurity hygiene. So in terms of sticks, legislation, but there are some benefits as well. But this is the extended landscape. I wanted to put this in perspective that we have so many other fundamental systemic issues that need to be addressed without having to focus on nation states, right? So the nation state part is just a tiny aspect of it. And then the reality check, industry trends. And everybody needs to be aware, right? Digital transformation, cloud analytics. The previous talk was about cloud, right? IT has made so much progress in cloud because you see the scale, you see the cost improvements, you see so many benefits. So that will slowly percolate to OT as well, but that increases the attack surface quite a bit for OT, especially because we had other problems. IoT projects that are happening every day. So IoT, as you all know, is I guess, a benefit overall because you can scale projects quickly, you can implement. I always use an example. Years ago, on a tank farm, I needed a level transmitter, and to get that properly commissioned, the level transmitter itself was like $500, but the cabling, the power supply, the PLC, the connectivity, the fiber to that PLC to that location for a couple of miles, all that totaled upwards of 50 grand just to get a level indicator, right? Level transmitter. But if you have an IoT level transmitter, that could be $1,000, but you got the signal right away. For $1,000 investment, you got your level. So IoT is pretty popular in the OT space as well, not just in IT. A lot of projects now start with IoT because it's cheaper, faster to implement. So that's going to continue to happen, right? But think about it. We just talked about how OT as a whole is insecure by design, and now you're connecting parts of it to the cloud directly. So when you were thinking it was isolated, you were safer, and now you have direct connections to internet every day because of this increased IoT use cases. And then retiring experienced professionals. This is a problem everywhere, I would think, but more so in OT because the traditional OT knowledge, those people have retired or are retiring more, and then the younger folks are not getting into OT, right? They're interested in IT, not necessarily OT. So I always pitch people, especially if you're not super excited about IT, but you have some IT knowledge, then consider OT because your IT knowledge is already probably max required. You're already good. You already know what needs to be known in the OT space with respect to the IT knowledge, but then you can learn industrial control systems, and maybe that's your deal. Risk analysis. Coming to OT risk and IT risk. Again, let's go back to Colonial. So if you were to ask the CISO or CIO of Colonial, what's your risk? They're not going to say, my IT risk is this, my OT risk is this, because it's irrelevant. For them, planned outage, right? Safety of the personnel, something being down, something being impacting the environment. These are all enterprise level discussions, not necessarily OT or IT specific, right? So why are we now not dealing with OT? Like we completely forgot about OT for so many years, just because we know how to handle things in IT, we know how to work out budgets, we know how to manage or mitigate risk in IT, so we focused on it, but we never focused on OT for so long, right? But it's meaningless to just think about IT risk on its own. You have to think about the whole enterprise. And then ransomware, for example, just affecting IT systems. Again, the connectivity from IT to OT has tremendously increased. So OT systems are a higher risk because they're not patched, they're insecure by design, they have so much collateral damage. And so just focusing on IT systems is irrelevant for the organization. So what can we do? Right? The solutions are the same. Just like in the Mandian recommendations, just like in the Schneider recommendations, the solutions are always the same. Identify, get asset discovery tools in place, get your network monitoring in place, right? Assess the vulnerabilities for your OT network. Figure out what is truly at risk. And then follow the monitoring protocols, right? So once you're able to put some asset discovery and network monitoring in place, you then can detect anomalies. Detecting anomalies in OT is a lot easier than in IT because OT is very deterministic. You know exactly what all things need to happen to get this process right. There are 10, 15, 20, 30 variables that specifically work together in a certain fashion. It's physics, right? Chemistry and physics are not going to change. Think about a chemical reaction. You need to have certain temperature, certain pressure, certain combination of molecules to get this reaction in place. That is not going to change, right? So if it varies, if your sensor says I got 10 bar pressure, when you know for a fact that chemical reaction cannot happen at 10 bar, because that's the game, chemistry and physics combined, you can detect anomalies quickly. You say, hey, this sensor is faulty, right? So anomaly detection in OT is a lot simpler, a lot more straightforward than in IT. And then the last point, reducing impact. This is another very OT unique thing that is an advantage. So think about the situation where we talk about attacks, right? In IT, let's say email server or any traditional IT server, it's vulnerable. Let's say there's a vulnerability out there. The only way to mitigate is to patch it right away, right? As soon as you get the patch, you update the patch. Log4j is a good example. You can't do anything without a patch. You have to patch it, and that's the only way you can mitigate the risk. In OT, actually, that's not the case. I have HMIs and workstations that have all kinds of malware, and that has no problem running the plant. Because as long as I'm able to block that malware from talking to its command and control server, as long as I'm able to isolate that device, I can still run my process. That has nothing to do with the malware, number one. And number two, reducing impact. This is another unique thing. Think about a tank, for example, overflowing, right? Let's say you have a dike, and let's assume that it's not poisonous, it's not a major chemical that can cause other environmental issues. But let's say you built a dike or a wall around the tank. So even if it overflows, the worst case situation is it's contained, right? So your PLC, your HMI, whatever is under attack, even in the worst case, somebody caused the tank to overflow, you're reducing your impact by something that's physical, something that has nothing to do with control system, nothing to do with digital. So there are things in OT that we can do, many, many examples where you can build the system in such a way that even in the worst case scenario, nothing bad happens. Kind of like the nuclear world with this containment area, right? That didn't exist in the Chernobyl location, but everything in North America is massive closed container. Same thing in Ukraine. Now, they're all seeing all this news about constant shelling. But most of these places have this massive built dome that limits everything, right? So nothing comes out of that. So there are things in OT that we can build for a lot less expense, and that's the key, right? If building that containment zone costs you 50 grand versus implementing basic cybersecurity practices costs you 5,000, you're gonna use $5,000 to do this. But in the OT world, there are many situations where fixing the whole system from insecure by design all the way to monitoring might cost you hundreds of thousands of dollars versus a containment or some kind of backup that might only cost you 10% of it, right? So that's another possibility. And then these other things, and these are the common threads across the world, right? Personnel training. Our OT people are not cybersecurity aware. It's improving, but as a percentage, probably less than 10%, in my experience, are aware. They're not networking people, they're not authentication, encryption people. So a lot of training required in the OT world, especially if you're using more IT-like solutions, right? Training is a big deal. Leveraging industry groups for intel sharing. It's happening more and more. Pretty much every vertical, oil and gas, mining, electric, and the power sector, there is information sharing, analysis centers, ISACs all over. So a lot of intel sharing is happening quite a bit, but more needed. Public Safety Canada is pushing a lot of common information sharing as well. And then tactical things, right? Establishing disaster recovery policy. It's kind of interesting how, like, you walk into a refinery, for example, you'll see their safety plan pin. The first thing you'll see as you enter is, as part of your safety orientation, you'll see their disaster recovery plan. You see their fire protection plan, their safety, who to call if something were to go wrong, but that doesn't include security currently. That has to change. Recovery time objective. Again, taking Colonial example, if you're Colonial and your recovery time objective is 6 days or 7 days, you're good. You just needed to tell people that that's your recovery time, right? You say, hey, I built my network, I'm resilient for X, Y, and Z, but my RTO is 6 days. So then people know that, yeah, for 6 days, maybe you won't have this pipeline or this company, but it'll be back up in 6 days. Conducting tabletop exercises, instant response, same thing. I've not seen Companies do this regularly. They are improving these days. Anyone here did a tabletop exercise that includes ICS? One, two, three. Yeah, it's increasing, right? Slowly, more and more people are trying to do it, but they need help. So IT, definitely leverage your best practices, right? Include ICS as well as part of the exercise. And then finally, it's not possible to 100% outsource OT security because IT, we've seen that, right? IT, as in more and more systems of network, more and more cloud utilization, you could outsource to an MSSP most of the systems. But in OT, because no matter what, you need the plant personnel to be involved. So they are the ones that can do forensics. They call it troubleshooting. They can troubleshoot the alarms. They can tell you if this alert really is a problem or if it's a false flag. So you need to have the constant involvement of the plant personnel. So you can't really 100% outsource it, but you can have an IR retainer, right? You can have external help for IT-like things, right? So there are many things in OT that are very unique. So you still need the plant personnel to be involved, but for other things, you can leverage IT-like tools. So the crux of my messaging, folks, is that media and in general, the news cycles focus so much on zero days and nation states attacking. So you hear about Ukraine, you hear about Iran, China. Is the nation's power grid at risk? Are we at risk for oil and gas disruption? You hear so much about that, but our problems are a lot more basic. Yes, at the highest level, you still need to think about those things, but we have fundamental issues in OT that are very basic, but still need to be solved. Any questions, folks? I must have been crystal clear.
But in reality, we have standards now, whether those be the TSA directives, whether that be your SIPs, right? That, as you said, can be very prescriptive. And the reaction of these nation states is in the media, and of course, all of the C-suite see it. And so what do we do as companies? We put in an IT solution, an IT or an OT now solution. So now we're taking, for example, allow listing, or right, and we're trying to, from an IT side, and now we're trying to force it into the OT operations. And the IT people, usually, now they're security experts, but they come from the IT world. And now they're trying to learn the OT, and there's that whole clash.
Right.
Which, as a cybersecurity VA, which is me, I'm in the middle of it.
Mm-hmm.
And I've been on the OT side doing documentation for certain SIPs, and now I'm putting in an IT package into the OT world. So how do we bring these two worlds together? And I know you're talking about training and all that, but it's these standards now are pushing this on OT, and is actually providing more risk to the OT environment because of this IT software, right?
Oh, great point. Let me unpack that a little bit, because for the context, right? We need more of these marriage counselors, number one. So we need more people like this, right? The problem remains that OT is unique, right? IT and IT security have done things based on what they know, and there's a lot of knowledge, a lot of established processes in IT that are really good, but not everything fits well in OT. So it's a push and pull. So OT, on the other hand, can't always say, we're so unique that don't let IT touch our stuff, right? We used to do that. I did that for many years, right? Because I can give you examples of where I needed this laptop, because that laptop, that particular OS version, that particular tool worked for my PLC. And that laptop, IT tells me that I need to patch it. If I patch it, I'm through. I cannot talk to that PLC. So for years, OT did not let IT touch our systems because IT didn't understand our world, right? Things are changing. We're using more IT-like tools at Purdue Level 2, Purdue Level 3. Every tool there is IT-like. In fact, they're exactly IT tools repurposed for OT applications. The only difference between this Dell server, this HP server that I'm using in OT, is that I've used a config tool for the PLC on my server, but the server itself is run-of-the-mill, no different from what IT used on their side, right? So we use more and more IT tools. Networking, switches, routers are very similar, if not exact same, in OT compared to IT. The only difference might be that some of this hardware might be ruggedized for the industrial environment. Other than that, the tool, the interface, everything is the same. So the bottom line is OT leveraged most of IT equipment in the past 15, 20 years to become more functional, more efficient. So they can't now say IT don't touch it, because IT is the one that knows how these tools work. On the other hand, the process, right? The one thing that IT doesn't have to deal with in the IT world compared to the OT world is the process: safety, efficiency, productivity, reliability. Things in a refinery, you don't care for data as much. You care for the process safety. You don't want the process to blow up, right? That's the part that IT has to learn. So what we're seeing increasingly is this collaboration. When a few years ago, the CIO and CISO had nothing to do with the OT world. Things changed. These days, the CISO, CIO, they're responsible. The CISO especially is responsible for the overall security of the company. So that has helped bridging the gap. The second thing that helped was forcibly putting people in places. So take an IT guy and put them in the production environment. It also helped training OT people on IT tools. Go get certification, go get training. So then at least you understand where they're coming from. Then you can differentiate between focusing on email security, for example, that has nothing to do with my reactor or my refinery process, right? So the training is mutual, not one way. Yes, IT has a lot of process, a lot of knowledge, a lot of capability. However, they lack the OT specific knowledge, right? That recognition has to come from the IT world. OT, on the other hand, has to also recognize, let's not reinvent the wheel. Let's not learn how to segment or architect my network because IT did this 15 years ago. Let's leverage best practices from IT. So the reason I put this in resources section is not only NERC-CIP. So NERC-CIP, so taking one piece apart from what you said, we don't have standards everywhere. We have certain regulations in certain industries and certain verticals, but not uniquely everywhere. So ISA IEC 62443 is that standard that is horizontal. It can be used in healthcare, power, oil and gas. So we have developing standards that are applicable across multiple verticals and industries. So you're seeing a lot of growth in utilizing and leveraging that, right? That'll talk about zones and conduits, segmentation. In fact, they have security levels where security level 1 would be, I'm trying to protect my plant against a wannabe hacker, script kiddie that just found my IP address on Shodan. To security level 4, where I'm trying to mitigate risk against a nation state. So there is a whole 1 through 4 where you're developing your program, because on day 1, no one can get to level 4, right? If you're a company that is looking at investment versus risk, you can't suddenly start thinking about protecting yourself against nation states. That's a step that you'll get to eventually, but there is a security level concept as well. And then others. So MITRE ATT&CK, we talked about it. I'm part of that top 20 secure PLC coding practices, programming PLC securely. CCE methodology, consequence-driven, cyber-informed engineering. That's another engineering, not security focus, but engineering, helping you build security in the OT space. So collectively, folks, IT and OT are talking, have to talk even more, and the bridging has to happen in a company. In certain sectors, in water, for example, there are no OT security folks. It's one IT security person that's responsible for the whole plan, no matter where this is. They're having to learn it the hard way, right? You can implement an IT tool like multi-factor authentication. Very simple. In the IT world, it's a given, right? Like, when would you ever say, don't do MFA? Like this, that's not a thing in IT. But in OT, that could be a thing, because think about an operator in front of a computer that has to adjust something or shut down a piece of equipment because something is wrong. You do not want them to forget their password. You do not want them to enter their second factor. You do not want any delay, not even a millisecond delay from their action. So that screen is always open. It's unlocked, no password, no MFA. That is the use case, right? So that's the learning that needs to happen.
So are there any associations where you can get these IT and OT people together?
Pretty
Like,
much
that's-
all these are all combined. So we're seeing a lot of OT and IT people participating in all these exercises
Okay.
and learning from each other. That's why I put these resources.